Okay, so I'm back for part 2 because my dog stole my pencil. So, okay, slant height. So what I was saying was some formula sheets call it lowercase cursive L, some formula sheets call it lowercase cursive S. I've always called it lowercase cursive L. I know that's a little weird for slant height, but that's the way I learned it. All right, so slant height is a little complicated, but basically it's the height of a lateral face of a pyramid or a cone. So it's the height of a lateral face of a pyramid or cone. Pyramid or cone. Okay, this is really important for formulas, so let me try to explain. Okay, if we were gonna find the surface area of this pyramid right here, well, we would need the area of this square, which would be easy, right? And we would need the area of 4 triangles, right? Well, to find the area of this triangle, we would need this base, which is the same as a side of the base of the pyramid. So we would need this base times this height. Remember, it's 1/2 base times height. So I would need this line and this line. Okay, that line right there, that's slant height. And the reason they don't just call it height is because they're keeping in mind the original shape. So the original shape is this pyramid, and the height of the pyramid is this distance right here. It's from that tip point to the center of the base. It's that height. Well, that's different than this height. This is a little longer, actually. So this, from the point to the center, that distance is a little shorter than this distance here, the height of the actual triangle. But that's what I need. I need to find this area of this face, I would need this line and this height. That's called slant height. So it's the height of the triangle, but in the pyramid it's leaning. So that's why they call it slant height. So it's that line right there. On the cone, you can draw it as this line right here. That is slant height. You can call it S, or you can call it lowercase cursive L like that. So either way, that height, sorry, Case, that height is leaning like that. That's called slant height. Like that. The dogs have gone crazy. This video is just like full of dog noise. All right, number 12. A cone. A cone has, a cone has one base that is a circle. One base that is a circle, and it's got one lateral face. So one lateral face, and that lateral face is kind of triangular. It looks more like, when you flatten it out, it looks more like a sector of a circle. But the reason I say it's triangular is because the triangle formula is what works to find the area of it. So we'll talk about that when we get to the formulas. But that one lateral face, if you were to unwrap a cone and flatten it out, it would be kind of triangle looking. It would look kind of like that. It actually looks more like a sector of a circle, like I said, but the triangle formula works. So we say that it's triangular. Okay, let's see, volume. Volume is the amount of space, the amount of space that a 3D figure occupies, that a three-dimensional figure occupies. You can call it a space figure, you could call it a solid. The reason I didn't put solid here is because it is possible for three-dimensional figures to be open inside. They still contain space. So I just didn't want that to be confusing. Occupies. The amount of space that a three-dimensional figure occupies. Now, volume is measured in cubes. So I don't know if you can tell, but I drew a tiny little cube inside this bigger cube. And I know it's weird, but even cylinders, volume is measured in how many cubes would fit inside it. And same thing with spheres. How many cubes would fit inside the sphere? So that's how volume is measured. Only three-dimensional figures have volume. So a rectangle doesn't have volume. A circle doesn't have volume. Those are flat two-dimensional shapes. Only three-dimensional figures have volume. All right, the next term is sphere. Sphere is a set of points, a collection of points, in space. Now, if you don't put that word in space, then this will be the same exact definition as a circle, and they are different things. So it's a set of points in space that are all equidistant from a central point, from a center point, I'll put. So if you had a point floating in space, so imagine that, there's a point right here floating in space, and you measured the same distance away from it, up, down, this way, this way, this way, this way. If you measured the same distance around, you would have this set of cubes that, or set of points, that are all hovered around that one point in the center. I know that's hard to imagine, but like if this was a center, this was just a point in space, and we measured out up and down and this way and towards us and away from us, and put dots in all those places, you would get this set of points that are circled around that center point in space, and that's what a sphere is. Okay, great circle. A great circle is a circle, of course, that has the same center as a sphere. That has the same center as a sphere. Okay, there's a little bit more to it. It's part of that sphere. Like if you sliced that sphere, it would be a circle that's right in the middle of the sphere. It would divide it into two hemispheres, they call it, two half spheres. And the diameter of this great circle is also the diameter of the sphere, or in other words, another way of saying the same thing is a radius of this great circle is the same as the radius of the sphere. It's called the great circle. Now, I could have drawn it in other places. I could have drawn a vertical great circle. I could have drawn a great circle at some angle. So there are more than just that one great circle. That just is a good place to put one. Okay, so the last thing I want to mention about a sphere, if you try to draw a sphere on paper, on flat two-dimensional paper, it'll just look like a circle. Because spheres are three-dimensional and paper is flat. So the best thing to do is to draw the great circle, and sometimes they'll draw it kind of dashed like that, and then the sphere kind of looks a little more three-dimensional. Now, some people who can draw really well do it with some fancy shading, which I am not so great at, but some of you are really good at it. But you could do some shading, and it would start to look three-dimensional, but yeah, I'm not so good at that. So this is how to draw it for people who are a little more artistically challenged. All right, so we're not going to do similar solids right now because, to be honest, I don't know if we're going to get to that. It's a section that we're skipping that I am hoping we get to come back to. All right, so that is all for the Chapter 11 vocabulary for now. I am going to do another video where I talk about formulas. So that's going to be a really important one for y'all to watch pretty soon. And so I hope that helps you as you go through Chapter 11 to know what these terms are talking about. So y'all have a great day. And I'm sorry about all the dog noise. I truly apologize. It was bad. Bye, y'all. Have a great day.